About math. So good afternoon, everyone. I'm going to record this office hours session and post to the YouTube channel. We're going to review material for the upcoming quiz on this coming Tuesday. So to start us off with that, we have a problem coming from the homework 2.1. This is problem 2.1.83. And, well, maybe I guess I just have to draw this, don't I? So we have something like this. It's hit 4 feet above the ground, and then it does a parabola type of thing. Okay, and they say that this is the y-axis, this is the x-axis, and so this trajectory represents a baseball being thrown. Okay, so what does it say? It says thrown. Yeah, I'm just writing it down. Thrown at an angle of 45 degrees with initial velocity of 128 feet per second. Okay, I don't think that's going to be relevant at all because they tell us that the height. Okay, so this is like the actual path that the ball takes, right? It's like I'm standing here, okay, and then when the ball is this far away from me horizontally, it is this tall above the ground, basically. That's what is happening in this picture here. So we have h of x is equal to negative 32x squared divided by 128 squared plus x plus 4. Okay, so the question, part A, is approximately how many feet did the ball travel horizontally? Is this the part that you wanted to ask about?
No, it's like C and down, so A and B is fine because it's literally just something in the graph.
Yeah, so to see, we'll talk about it just anyways, just in case somebody wants to know. Well, they tell us that the x distance represents horizontal distance. Can someone close that door for me, please? Thank you. The x distance corresponds to horizontal distance, and the y corresponds to vertical distance. I guess that's how the usual world works, right? So how many feet did the ball travel horizontally? We're looking to measure this distance from where we threw it to where it landed, right? That would be the distance that it traveled horizontally. So on my graph, it looks like, I don't know, 510, maybe 510, something like that, because this point here is the point 510, 0. So it went 510 feet. So, it gives us an option. That's nice. Good job. Okay. How high? Well, we look at the height of the graph. Well, on my graph, it looks like the height is probably like, I don't know, 130. So there we go. Good job. And now we're supposed to use the function h to find answers to a and b rounded to the nearest integer. I see. Okay. So the next question is, supposing that I didn't have the graph, okay? So forget about the graph, and imagine that I only had this function. And the question is, can I still answer these questions about when, or not when, but how far away horizontally does the ball land?
You're covering.
Thank you. How far away horizontally does the ball land? So this is a question about an intercept, right? It's a question about an intercept. So if I have my graph here, right, it looks something like this. Well, when the ball lands, that means that the height of the ball above the ground is what? 0, right? So if the height is 0, how am I going to modify this equation? Well, where does the height come into play here?
Y.
Yeah, it's the y, i.e. the left-hand side, where it says h of x. That's what the height is, right? So if I'm asking how far away horizontally, I'm looking for an x value such that if I plug it into the right-hand side, I get 0 on the left-hand side, right? That's what I want to do. So I want to solve the equation negative 32x squared over 128 squared plus x plus 4 is equal to 0. That's my goal, right? Okay, so who can help me solve this one? How would I solve this one?
You can simplify x squared.
Sorry?
Can you simplify x squared?
Simplify x squared?
Oh, I miswrote that.
So, whatever, squared 128, and isolate x, or turn it into a, what's it called? Yeah.
So we have a function here. Yeah, factoring, right? That's what we have. We have a quadratic function here. We have two methods by which we can solve a quadratic function. The first method is to use factoring, right? So here's why I don't want to factor. Look at these atrocious numbers here, right? Even if we simplify this, what is that going to be? 32 goes into 128 4 times. So this is like x squared over 128 times 4, which would be x squared over 512. So to do the AC method, would we even be able to do that? We would get 1 over 512. Welcome, Lauren. And then we'd multiply that with 4, right? And we're not going to get a number which we can do the factors of. So grouping is going to leave us with no options here, right? But we still want to find the x values, which cause this equation to be 0. But it turns out factoring was a bust. So do I have any backup plans?
The negative b plus or minus the square root of b squared.
Exactly. What's that thing called? The quadratic formula. Very good. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's exactly what we're going to do. So I know that a is 1/512th, and b is 1, and c is 4. Yes? So let's go ahead and do it. It would be x equals negative 1 plus or minus the square root of 1 minus 4 times a times c. That's 16 divided by 512. Someone got a calculator on them? Can you use it for me? So 16 divided by 512, I think is going to be...
0, 3, 1, 2, 5.
No, can you do 15? Sorry, can you do 512 divided by 16?
32.
32, right? Okay, so this is 1 over 32, right? Okay, so minus 1 over 32, and then we divide, and then what comes down here is 2 times a, so this is 2 over 512. Okay, so how do we go about getting from here to a decimal? How do I go about getting from here to a decimal? Not sure? Are we stuck? How can we get to a decimal?
What did you just
Yeah, how?
Square root.
Start with the square root. Okay, 1 minus 1/32. What does that get me? 31 30-seconds, right? So what is 31 divided by 32, Chris? Can you do that for me?
Uh, 0.97.
0.97?
Yeah.
Okay, and can you do the square root of 0.97? Maybe I have to go sideways mode.
We won't have to do a fraction thing like this on the quiz, right?
Well, I wouldn't give you anything that you can't do without a calculator on quiz.
Would you give us something like this?
0.98.
Like with
Fraction
with the fraction in the
Thing.
function?
What do you mean?
Like this kind of question that's like really difficult.
Well, the problem won't be difficult because of basic arithmetic. The problem I could definitely ask you, here's a parabola, find the x-intercept, which is essentially what this question is asking, right?
Mm-hmm.
I could absolutely ask that. So let's finish this one off. So I do this, I get -1 plus or minus 0.9848 ... whatever. Okay, and then what do I have to do? I have to divide by 1/256, which is the same as multiplying by 256, yes? Okay, so let's ask ourselves, what are we going to get when we're on the inside here? Well, if I do -1 minus something, what is that going to give us? What kind of number? If I do -1 minus 0.9848, I'll get -1.9848, right? Which is a negative number. Why do I not care about that solution to...
Go backwards.
Because that's going backwards, exactly. What does my parabola look like? Let's do it. Another drawing really quick. Remember what it looked like? It was something like this. Yeah? So what they're saying is, yeah, okay, if you go backwards, there's another root over here, but that's not the direction we're throwing the ball, okay? The ball is just going to start at this part of the parabola, and it's going to go up here, and it's going to go down here. Yeah, so I want the root which is positive, yes? That's the root that I'm looking for. So what I'm going to do is I'm going to forget about the negative version, and I'm just going to add. So if I... Hang on, something's wrong, though. Something's definitely wrong.
I don't like this question.
Something's definitely wrong because if I add... It'd still be negative, right?
Mm-hmm.
So what did I do wrong? Let's look back at the problem. Did I write it down wrong? 32x squared over 128 squared plus x plus 4. Ah, it's negative. So it shouldn't have been... When I did a times c, a was -1/512. So this should have been -1/32. So this should have been 1 plus 1/32, which would have given us... Okay, let's do it. So 1 plus 1/32 gets us 1.03. We then have to take the square root. How do I ants? I don't have an ants button. Square root of 1.03. Fine, I won't use ants. Gives us something like 1.01488, something like that, ... Okay, so then what do? We just add, right? Which leaves me with 0.01488 times... Still feels like it's going to be way too small. 256 minus 1 times 256. That's giving me 3.8. That can't be right. So what have we done wrong?
Do you know what the answer is?
Yeah, it should be something like 520.
532 is the answer.
Okay, 128 times 128
You should have
divided by 32
Is it?
is 512.
On this one, it's not 128. It's 130.
Yeah, every question's difficult. I mean,
Yeah,
different
they'll all be different. But still, what we got is way wrong for our
Becomes the same.
purposes.
I figured that out.
Yeah, it's always the same.
So let's see what I have done wrong.
There were only like 4 problems
Yeah.
that they recycled. So-
1 over 512. A is definitely correct. B is definitely correct. And C is definitely correct. So the only way that I could have fucked this up is if I... That's more like it. Okay, so because A is negative, so the bottom shouldn't have been 2 over 512, it should have been negative 2 over 512. So this should have been negative 1 over 256. And so when I look at this and I think, okay, I'm going to take negative 1 plus or minus this number and then multiply by not 256, but I'm going to multiply by negative 256. There we go. Now I got it right. Sorry about that. So now if I think about it, what is going to be the answer which I'm going to ignore? I'm going to ignore the answer where I add 1.01, right? Because then I would get something like 0.01, which is positive, and I'd multiply that times negative 256, and I'd get something negative, which is what's going to give us the wrong root. I want the positive root that's way out there. So what I'm going to do is instead of adding, I'm going to subtract. So I want the one where I subtract. So I get negative 2.01488 multiply with negative 256. And that gets me something like, let's see, 2.01488 multiply with 256. I'm getting something like 515, roughly, point something. Welcome, everyone. Okay, so now we did it right. Does that...
We can't.
Oh, you can't see it. Thank you. Jesus. Gotta say something. Okay, so let's go back through it again. So the question was, how far away horizontally does the ball land? We have a quadratic equation. The problem with this quadratic equation is that it's not easy to see how we would factor something like this, right? So rather than factor, we applied the quadratic formula. To apply the quadratic formula, the only thing we had to do was figure out what is A, what is B, what is C, and then plug into the formula. And that was a pain in the ass, but we made it through. And once we did, we recovered 2 solutions to the quadratic equation, which give us the x values of the x-intercepts, right? One of them is negative. The one that's negative is not the one that I care about, because I'm not throwing the ball down and to the left. I'm throwing the ball up and to the right. Okay, so I know it's not going to land, just based on my understanding of the universe. It's going to land somewhere to the right, okay, because I threw it to the right. So that's the root that I want. So there's some interpretation at this point where you have to say, well, my ball is going to go for a ride on this parabola, but the direction that it goes for the ride is up to your own interpretation. But there's only one interpretation that makes sense in terms of how we understand ball throwing to occur, I guess. Okay, so this problem is probably not something that I would put on like a quiz or an exam. It's too complicated, too much plugging, too much calculation. Okay, something that I could put on an exam would be something like, I throw a ball which travels according to the parabola. I don't know, let's make one up. How about negative 2x squared plus x, and then plus 2. Something like that I could ask you about. Okay? So let's say I throw it and it leaves my hand at the point 0,2, right? So imagine something like this. You know this is a parabola which opens down, right? And if I plug in 0 for x, then obviously I just start at 2, right? And then the parabola is going to do probably something like this, right? And then I could ask you, at what x value will it land? Okay, that's a more realistic question that I could ask you. So then what would you do? You'd either factor or you'd use the quadratic formula. If we use the quadratic formula in this case, we'd get -1 plus or minus the square root of 1 minus 4 times 2 times -2. That's plus 16 all over 2a, which is -4, right? And so from here, then you could ask yourself, okay, well, if I subtract this positive number from -1, then the numerator will be negative, and the denominator will be negative. And since we divide a negative number by a negative number, that's going to give me the relevant positive square root. Is that clear? More or less? Okay, this is much more realistic in terms of what I could ask on a quiz. All right, did I answer all the parts of the problem that you were wondering about? Yeah? Okay. Yeah.
Can you do question 7?
On which homework?
2.1.
On 2.1, question 7. Sure thing. Are you sure you want to leave this question? Yes, I am. All right, so let's do some more. God, I don't understand why this is so small. I feel like oh, it's because I'm plugged into the projector. I was like, why is the text so small? It's because it changes like the resolution of my screen when I plug into the projector. Okay. All right, so we want to graph the given function. And, okay, so they say y is equal to 3x squared minus 6x plus 5.
Could you make it so we can see it?
As soon as I finish copying, but yeah. By writing in vertex form. Okay, now you can see, right? All right, so let's see how we do one of these. Okay, so we have a quadratic function, right? Quadratic function is going to be a parabola. Which direction is it going to open? All together? Up, right? Why up?
That's positive.
Because what's positive?
A.
A is positive. This number attached to the x squared is a positive number, and therefore this parabola opens up. But it's not clear to me, looking at this, where is the vertex? And, you know, is it going to be stretched? Is it going to be reflected? Like, what's going on with all of this? So I have to convert it into vertex form so that I can see what that looks like. So after some work, what I hope to have is something of the form a times x minus h quantity squared plus k. This is what I want to eventually have. But I need to do something in order to transform it into vertex form. Once I have it in vertex form, it's very easy for me to do the graph. Well, not very easy, but very easy as it compares to trying to do the graph of something like that. Okay, so what I need to do is create a perfect square where before there was no perfect square. Okay, so how do I start with that one? Remember, what was the first step in getting a general form quadratic into vertex form?
Take out A.
Yeah, take out A. That was the first step. So A in this case is 3. Am I going to take A out of everything?
Just 3x squared.
Just the first two terms, right? Okay, so I'm going to leave the 5 alone pretty much throughout this whole process. So I'm going to replace 3x squared and then minus 2x. Yes?
Okay.
And then I put the plus 5. Okay, now what can I do?
Divide the middle term, well, B by 2 and then square.
Yeah, what's that process called?
Completing square.
Completing the square. I'm going to complete the square inside. So what do I do to complete the square? I take whatever this number is. In this case, it happens to be negative 2. And then I'm going to do what? I'm going to divide it by 2 and square it. So if I take negative 2, if I divide that by 2 and then square it, what am I going to get? 1, right? Because negative 2 divided by 2 is negative 1. Negative 1 times negative 1 is 1. So I'm going to add and subtract 1. So let's rewrite. We get 3, and then inside I'm going to put x squared minus 2x plus 1 minus 1. Okay, somebody help me finish this off. We're nearly there, but what do I still have left to do? You tell me what to write.
Factor the x squared minus 2x plus 1.
Okay, so if I factor that, I get 3, and then inside I'm going to have x minus 1 squared, right? And then minus 1, and then plus 5. Okay, what's next?
Move the negative 1 to the outside.
Yeah.
Parentheses.
If I move it to the outside, am I just going to subtract 1?
And now you're gonna
Add 1.
I'm going to add 1?
well, you'll subtract it, yeah. So it'll be 4.
So,
Wait, no, you have to multiply by 3 first.
that's
Then you
right.
have to move it
We have to multiply by 3 first if we're going to move it out. It's that pesky, it's inside the parentheses here, right? It's being multiplied by 3. This is not a negative 1. This is a negative 3, right? Because it's being distributed. Okay, so I get 3, and then I leave x minus 1 in here, and then I have minus 3 plus 5. And now I have 3x minus 1 squared, and then this just becomes plus 2, yes? Okay, so now this is much more friendly for graphing. Someone help me, where is the vertex going to be? What comma what?
1, 2.
1 comma 2. What about this minus sign? Why isn't it negative 1?
Because it's in the general form.
Because it's in the general form. In the general form, it says x minus h plus k has vertex h comma k. Okay, so if it says minus 1 inside the parentheses, then the vertex's x coordinate will be at 1, positive 1. And the y coordinate will be whatever this number is, 2. Okay, so the vertex is at 1 comma 2. So let's graph. I'm going to put a point here at move over 1 and up 2, right? So here's the point 1 comma 2, and I know that the parabola opens up. If I go over 1, how much should I go up? How can I tell how much should I go up if I go over 1? I should go up 3, and the reason is this is a transformation of the function x squared. Okay, what do? I move it to the right one, and then I stretch it by 3, and then I move the whole thing up 2. That's how the transformations are applied. So I know that normally on x squared, it goes from 0, 0, we go over 1, we go up to 1, 1, and then we go up to 2, 4, and then we go up to 3, 9, right? That's how it goes. So if I go over 1 from the vertex on my normal graph, on my normal parabola, I should have put this point. I should just erase that point altogether and then put it somewhere up here, right? 3 comma 9 is here. Okay, so on the normal graph, if I go over 1, I go up 1. But I have a stretch, a vertical stretch, so I'm going to go up 3 times as much as I would have otherwise. So I'm going to go up 3. So I'm going to go over 1. So it's going to be the point 2, comma 5. Because I should go over 1 and up 3. And then same thing on the left-hand side. I'm going to have 0, comma 5. Okay, how much would I go up if I went over 2 units? Normally, I would go up 4. If I went over 2, I would go up 1, 2, 3, 4. But I need to do 3 times that much upward movement because of this 3 here. Yes? So instead of going up by 4, I'm going to go up by 12. So the next point would be something up here like 3, comma 17. Yeah? And then I'd have negative 1, 17. Okay, and so on and so forth. So you'll notice that my parabola here is a lot thinner or compressed, or not compressed, but stretched in the vertical direction, right? It gets stretched in the vertical direction. So I grab onto it here, and I grab onto it here, and I pull in this direction and this direction, yes? And that stretches this whole thing out. Any questions on this one? So can someone give me the summary? Someone give me the summary of the steps that I need to take to graph a quadratic function like this. What are the steps? Yeah.
Can you just explain like one more time why like it went up 12?
Mm-hmm. Yeah. Sure. So maybe it would help if I did a Desmos. Let's do a Desmos. No. Okay, let's take a look at 2 functions. The first one's going to be x squared, and the second function is going to be 3x squared. Agree? Okay, so let's take a look at some of these points here. So I'm not gonna use the iPad. I'm gonna literally stand up and point at the screen. So for x squared, right? We know that the blue graph is what we get when we take the red graph and stretch it vertically. What I mean by stretch vertically is that for each point which is on the red graph, to get the point on the blue graph, I'm gonna take, the x value is gonna be the same, but the y value will be 3 times whatever the y value was before. So let's take a look at this point here on the graph of x squared. It's the point 1, comma 1. If I were to stretch this by a factor of 3, instead of having the point 1, comma 1 on the graph, I'm going to instead have the point 1, comma 3. Because I took the height, which was 1, and I multiplied it by 3. So that takes us to 2 up to 3, right? Now let's take a look at the next point. So when x is 2, what is, okay, I don't have long enough arms to do this, but when x is 2, what's the height of the red graph? It's 4, right? So how am I going to get the height of the blue graph? I'm going to take the height of this point, which is 4, and I'm going to multiply it by 3. Does that make sense?
Yeah.
So that's how I get the maybe I can point at it now. That's how I get the height of, so this was the point 2, comma 4. For the height of the blue graph, it's not going to be 2, comma 4, it's going to be 2, comma 16. Okay? 2, comma, wait, am I looking at the right spot? 16.
It would be 12.
4 times 3 is 12.
What am I doing? Yes, Jesus, thank you. I was like, why does that look so wrong? 3 times 4 is 12. So it's going to be right here. Okay, so the idea here, okay, the only difference between the idea here is that, and the one that we just did, is that in addition to this vertical stretching, I also have a shifting. Okay, so I didn't just have this this stretching. I had the stretching and move it to the right 1 and up 2. Okay, so if I just had 3x squared, right, it would start here, we'd go over 1, up 3, right? But in this case, our vertex is here, so we're going to go over 1 and up 3 in the same way that we would normally do it on the graph of 3x squared, but I have to move it up and over a little bit. So does that answer your question?
Yeah, that's why like it was 17 instead of 15.
Exactly, 17, because it should be
15 with add that extra 2. Right?
yeah, we need to add. No, wait, something's wrong here. Yeah, something's definitely wrong. It shouldn't be 17. It should be okay, on 3x squared, if I were to go, okay, if on x squared I go over 2, I would go up 4. On 3x squared, I'm going to go up 12 instead. So, but I'm going up 12 from 2. So this should be 14. Sorry about that. Mistake on my part. So over 1, we go up 3. Because on the graph of x squared, normally we would go over 1 and up 1. From the vertex, if you count from the vertex and we go over 2, then we would go up 1, 2, 3, 4 on the graph of x squared, which means we need to do 3 times that amount of shifting, or amount of movement for this one. So instead of going up 4, I'm going to go over 2, and I'm going to go up 12. Okay, that's how I get to this point here. That's 12 higher than where we started, which is, we started at 2, so 12 more than that is 14.
Okay. So then is that supposed to be 2 comma 4? Is it still 2 comma 5?
I think I did this one correct. This one should be 2 comma 5, because on, okay, let's do 2 graphs here really quickly. One will be the graph of x squared. It has the points 1 comma 1 and the points 2 comma 4 on it. If we were to do the graph of 3x squared, then it would have the points 1 comma 3 and 2 comma 12, as we just established, right?
Yeah.
So it would look skinnier like so. Okay, and then what is this graph? This graph, 3 times x minus 1 squared plus 2, is the graph of 3x squared shifted to the right 1 unit and up 2. So if I took the point 1, 3 and I moved it to the right 1 and up 2, then I would be at the point 2 comma 5, right? I move to the right 1, that makes 1 into 2, and then up 2, that makes 3 into 5. So this point is the point 1 comma 3. Its analog on this graph is the point 2 comma 5. And what should be the same about these two graphs is the shape of the graph, i.e. what is the distance between this point, the vertex, and the new point should be the same on both of these graphs, because the one is just the other but moved to the right and up. So we didn't do any further stretching. Does that make sense?
Yeah.
Yeah, it's kind of confusing the first time you see these, but really all I'm talking about here is the ratios of how far should I go up, and then I just ask, well, where do I start? I need to go up by the same amount, up and over by the same amount, so I just do that process but in a different place. That's kind of how I think about it. But there may be other ways in which you could think about it that might make more sense to you, and that's totally fine as long as you get the same points. Any other questions on this one? So can someone summarize, how do I graph a quadratic when it's in general form?
Factor out a, then you put the square of that as x squared and b left.
Mm-hmm.
Then you multiply it, then you factor out, well, not factor,
You take out
you take out -1.
the extra minus that we introduced, right? That goes all the way out, and then
You'll combine c, and then you'll have the complete.
and then we will have it in vertex form, right? So the whole game here is to take a formula or a function which is in general form and transform it into vertex form. Once we have it in vertex form, we can graph it by using the theory which we learned in section 1.7 about transformations of functions. So we learned our celebrity functions, and we learned the general shape of them, right? And so now we also have all of this understanding of how do I move them over to the right, over to the left, up, down, stretch them up left, and sideways, right? All the different ways which we learned how to transform the graph of our celebrity functions. So it's to rewrite this in vertex form, then plot. Okay, next question. Maybe another one from the homework. We got a couple homework assignments due tomorrow, right? Which I guess maybe I should extend those. Because I feel like somebody is gonna like lose power or something, so I don't want.
Columbia Hall is so dumb as hard. There we are.
Don't say that.
So many ancient, McBride's probably gonna lose it too.
I'm scared about Woodrow.
I'm not scared about East Quad because we're the best.
Yeah. So nice.
We've lost Wi-Fi like 4 days in a row.
Don't
At least on my
talk
I
phone.
always
shit
think
about
the
East
quads
Quad.
are
No, we
nicer
actually, our
than
Wi-Fi
ours,
is
so-
probably the
Some
worst.
Hmm.
Like, I'll be doing my math
No, I don't
homework,
have to
I
have
got
Wi-Fi.
Ethernet.
and I will not be
Yeah,
able to
Ethernet's what you
internet.
need.
What
Yeah.
is it?
Ethernet or like
That's
Yeah,
wired
how
Wi-Fi?
wired-
Wired connection. That's where it's
So
at.
do you know like Ethernet cable or anything like that?
Hmm?
They're allowed to do that?
Wired,
Yeah.
wired.
Like, you have like these
It's
little
like-
boxes. You have those boxes.
I know, I do, but like that's.
That's what
Wired,
that's
wired.
Yeah, use that.
You can also just plug it into your TV, so like you can like hook up like your
Go to
Netflix and
CVS, you
Hulu
can
and
buy
all
a
that.
Ethernet cable for like $12 and you can plug it
I'll just
into
tell
your
them.
It'll be
That's
cheaper than
$12
$12
here.
probably.
Yeah,
Also,
You can get like a-
large
So
cable,
like if you
yeah,
have
so
like
mine
a
was
MacBook,
$12.
like you're gonna have to get like.
You're gonna have to
some
get a
sort of,
dongle.
Yeah, like a
Because that's what I have.
They also
Oh yeah,
have
it
this-
wouldn't work for your laptop.
I would like, that's just so much work.
It's like
so
$15 in total.
That's
Really?
like so much
Okay.
work to like have to like put.
It's like 15.
And
And y'all are just sharing this like now.
Oh,
I feel like it was
Most
a lot.
people.
You didn't know about Ethernet
Yeah.
before?
Have you ever used Ethernet?
Ethernet.
One of my professors made us get a whole.
Like for example, like how do you think internet gets to this computer?
It's an Ethernet.
There's like a
It's a
cord.
cable.
It goes through a cord. The
That I
cord
know.
is called an Ethernet cable.
So
That's
you-
all
How
it
would I
is.
know that?
That's a wired.
Have you never
Wi-Fi.
used like a desktop?
No.
I mean, I've heard of wired.
Have I used one? Yes.
Internet?
Has it been
I thought
like
it was the
multiple
Wi-Fi.
years? Yes.
The only time I've used like a desktop.
It was in, like,
it's like
middle
in,
school.
It's like in middle school,
be
like
good
high school.
to
This is
use.
like a computer type of class. So like, I'm
Okay, I don't want to get too off topic because I don't want anyone to be sitting in here and miss the problem that they want to talk about. So what should we talk about next? Does anyone have a problem from 2.1 or 2.2 that we want to talk about?
Say whatever else is on the quiz.
Yeah, that's what I was about to say.
Yeah. What
Just
can you
like
give,
show
what can
us
you give
the
us?
Things about the numbers, and you know.
What can you give us today?
Yeah.
For the low price of
for a 3-day weekend.
For the low
we can
price of
study.
internet.
Yeah, exactly. I didn't actually study that.
Just like, yeah.
Well, like, I think it's like ether. Like, it just sounds like something.
For a lower price of a bag of chips. How much does
Yeah,
it
why
cost?
would
No, I'm not giving up my
I
shit.
would go back to
That's
chips.
I only have two, so.
Yeah, that's why I'm in the major that I'm in now. Because
Is it Celsius?
Okay, let's do this one.
and also,
We should have one letter.
also I got low advice. Like
My favorite
that on top of like drinking this every
I've
day.
never had Celsius or Red Bull.
COVID 3 times the best thing.
COVID
COVID 3 times the best thing.
I used almonds because
I have not done it.
I used to
How can you change that around?
Like,
X squared and then 6x and then
All right, everybody, let's settle down. I know it's an exciting time talking about Ethernet and all of that.
Her resting heart rate is
We love
160.
it used to be, yeah.
160?
It used to be because I used to drink these like
Celsiuses
every
are
single
literal
day.
poison.
And
They're
then I had
poison.
COVID twice, like I couldn't like breathe, and I felt like there was like something sitting on my chest.
Dude, you're gonna get a heart attack at like 25.
That
It's
does.
better now. My heart rate's like 70.
No, something similar happened to me
That's a really
one
Your
time.
resting heart rate?
Resting heart rate for 70 is good.
70's good.
70's fine.
Oh, mine's like.
Okay, I have a story about that, which I'll tell you really quickly.
That's like sleeping for me.
So one summer when I was like a sophomore in college, I worked at a bank over the summer as like an intern. Basically, I was just like a teller.
Yeah.
But the bank that I worked at was like they marketed themselves as like a high-end bank or like a high personal service bank or whatever. And so they would put they would overstaff their banking centers. So as a result, like as a teller, 99% of the time you had absolutely nothing to do. And the bank also, as like a benefit for their customers, would provide unlimited free coffee. And so if you worked at the bank, you could also drink unlimited free coffee. And so I had absolutely nothing to do for like 9 hours straight at a time, and I would just drink the coffee because there was just nothing better to do. And it got to a point where I was drinking I think 8 cups of coffee a day or something like that. And then I started having heart palpitations, and I was like, and so I went and
No, it's not fun at all.
and so I went and talked to my dad, who's a doctor. I was like, my heart is going crazy right now, and he was like, how much caffeine are you drinking? And I was like, does that matter?
The same exact thing happened to me. I worked at an Italian restaurant from when I was 16 until I came here, obviously. And there was a coffee bar across the street, and they always gave us free coffee. I knew all the people that worked there, so when I would go in, I'd get my coffee. When I finished it, I would get another one. And then we had an espresso machine at the restaurant, and my shifts would be 16, 17 hours a day. So I would be taking an espresso shot every 40.
A day?
I would be taking
It's illegal.
no, it's not legal for them to keep me working that long. But I would be taking an espresso shot every 45 minutes and then casually sipping on a coffee and having heart palpitations, and my mom freaked out. She's like, "What's wrong with you? Stop drinking caffeine." I was like, "I'm sorry, I need to stay awake somehow."
That's why I started
I just get
drinking
migraines,
Celsius.
so I would
used
I
to
would
work
eat that drink
and
I'm there.
All right, we should really do this problem. So let's do it. Let's get back on track. All right, we all ready?
Sure.
Okay, so this is one of the questions that's on the homework. What question is it?
Would you say this might be
It's number 9 or something on the homework.
Which one?
9 on the quiz.
All of it's viable for the quiz, but we're going to talk about most of the things as long as we can stay on task here. So let's talk about this function. F of x equals 9 minus 6x plus x squared. The question is, does this function have a maximum or a minimum value? Well, what do we think about that? Is this function going to have a maximum or a minimum value? I'm hearing maximum and minimum. Can someone who said one of those justify your answer? Sully.
Minimum because the x squared is positive.
It is a minimum because the x squared is positive. I like that, okay? It's an argument which has evidence to back it up, right? It's a minimum because the x squared is positive. Because the x squared is positive, I know that this parabola is going to be opening up, right? It's going to open up. It's going to open up because the a value is 1, positive 1. So it's going to open up. If a parabola opens up, it has a minimum value, not a maximum value. Okay, so I agree we're going to have a minimum value. Okay, so now let's find it. Well, how do I do that?
Probably put it in quadratic.
What was that formula called?
The vertex form, right?
Yeah,
Okay, so why is vertex form going to be useful? Because we want to find the minimum value. Well, where is the minimum going to occur? It's going to occur at the vertex, right? Okay, so let's do it. So first of all, I heard another question, which was why does this look like this? Can we just rearrange it? And the answer is absolutely yes, we can rearrange it. We can write it's just x squared minus 6x plus 9. Okay, no problem with doing that. Okay, so I like rewriting it like that. So now, what I'm supposed to do first when I put it in vertex form is pull an a value out. But what is the a value? It's 1, so I'm not going to worry about it. So we complete the square on x squared minus 6x. How do I complete the square? I take that number, I divide it by 2, and then I square it, right? So I get negative 6 divided by 2 square it. That gets me negative 3 squared, which is positive 9. So I'm going to, am I going to subtract and add, or am I going to add and subtract?
Both.
Well, I guess both. But which one am I going to do first?
Add.
I'm going to add first. So minus 6x plus 9 minus 9. Oh, I guess, and then plus 9. It was already in factorable, isn't it? Right? What is that? X squared minus 6x plus 9. You don't even need to complete the square, do you? You don't need to, because this is already x minus 3 squared. Okay, so f of x equals x minus 3 squared. Where's the vertex?
3, 0.
It's at 3, 0. So the maximum value, or minimum value of this function is that? Yeah, that's fine. Yeah, minimum value. Yeah, because 3 is a double root. Okay, yeah, minimum value is 0 when x equals 3. So this is a situation where we have a double root, right? We have a double root, so it looks something like this. Okay? So that is one way in which we can see where the minimum value is. Well, for a parabola, the minimum, if it opens up, it will have a minimum, and the minimum occurs at the vertex. If it opens down, it's not going to have a minimum, is it? It's going to have a maximum, and the maximum is again going to occur at the vertex. Yes?
Can't you also do like the vertex thing where it's a negative b?
Yes, you can. You can always do that as well. So another thing is the vertex of ax squared plus bx plus c is always located at negative b over 2a, comma, f of negative b over 2a. So what does that mean? What that means is if you wanted to find the vertex of a function like this, you could put it in factor it or put it in vertex form or whatever, right? Or you could say, well, I know the vertex is going to be at negative 6 over 2 times a, negative 6, that'd be positive 6, over 2a. A is 1, so this is 2 times 1, right? So that would be 3. So I know the x value of the vertex would be 3. And then how would I get the y value of the vertex? I would plug it in. I'd get 9 minus 18 plus 9, which would be 0. So that would be another way to get the vertex. Does that answer your question, Sully? So yes, that's also fine. You can memorize that the vertex, the x-coordinate of the vertex is always negative b over 2a. And then from there, you can easily find the y-coordinate, right? All you have to do is find whatever negative b over 2a is and plug it in for x in the function, right? Okay, so that's another way you could do that problem. Any questions on that? Okay. Then let's move on to another problem. You want me to pick or you want to pick?
You do 22, 2.2.
Yes, let me quickly see if there's anything else interesting in this one. Oh, let's do this one. Yeah, let's do this one. Okay, we have 480 yards. Weird measurement, but okay. Of fencing. And we want to enclose a rectangular area. Find the maximum area possible. Okay, so very abstract kind of a problem. Okay, anytime that we have an abstract kind of a problem like this, I think the best place to start is definitely to draw a picture. Okay, why don't I just make a rectangle? That would be smart. There we go. So here's our rectangle. So we are supposed to enclose a rectangular area using 480 yards of fencing. And my goal is to decide how wide should it be and how tall should it be, right? In order to get the maximum area possible, right? So I'm talking about different possible fence structures, right? I could have one that's like really long and skinny, yeah? Or I could have one, I could use up 480 yards of fencing to make something more square shaped, or I could make it really long and skinny in the other direction, right? Something like this. Okay, so these are my options, right? So my goal is to decide how long should the sides be, right? That's my goal, is to decide how long should the sides be. So the way we do this, okay, is we just have to make a function for the area, okay? We need to make a function for the area. And what we need to choose is basically how long is one of the sides going to be, okay? Here's why. If I choose that this side length is length x, how long is this side?
X.
Also x, right? And then can someone give me, I claim that we also know how long these two sides are. Could someone explain why?
Is there 480 minus whatever the x is?
Exactly, I know how much I used up already, right? I have 480 yards of fence, right? I used up 2x so far. Agree? So this is the amount of leftover fence which I have to build this side of the fence and this side of the fence. And I'm just going to split it evenly, right? Between each side. So 480 minus 2x all over 2. That is this length, okay? Which is going to be what? 240 minus x. And then we put 240 minus x right here. So these are the lengths of our fence. So what is the area that is enclosed by our fence? How do I get the area of a rectangle? Length times width. The length is x. What is the width? 240 minus x. So I take those two numbers and I multiply them together. So x times 240 minus x. That is the area which is going to be enclosed by our fence. So what kind of function is this? What kind of function is this? It's a quadratic function, right? And is this a quadratic function that opens up, or is it a quadratic function that opens down?
Wait, no, it opens down, sorry.
We think down, right? Because if we distributed this x, then we would have, this would be 240x minus x squared, right? 240x minus x squared. Because the coefficient on x is negative, we know that the parabola opens down. Does a parabola that opens down have a maximum? Yeah, it does have a maximum, doesn't it? So let's try to find the maximum. Find the maximum. Where does the maximum occur for a quadratic function? It occurs at the vertex. What's the vertex of this function going to be? How can I tell? It will be at negative b over 2a, f of negative b over 2a. What would I get if I took negative b? What's b, first of all?
240.
B is 240, and what's a?
X squared.
X squared?
Well, negative x squared.
It's just the coefficient, so it's just negative 1. Okay, so in this case, that is going to come out to be 240, negative 240, divided by negative 2. So what would I get if I did that? I'd get 120. So I need 120, and then the y-coordinate will be f of 120, right? Okay, so f of 120 would be whatever I get when I plug that in, right? So x should be 120. So what does my fence look like? I have 480 yards of... Why don't I keep doing that? I should just do this. I have 480 yards of fencing. I use up 120 on this side and 120 on this side. How much do I have left? I had 480 to start with. I used up 120 on this side and I used up 120 on this side. How much do I have left? I have 240 left. And I split it evenly between this side and this side. Yes? So these sides are also 120. Yeah?
So it's a square.
So it's actually a square. Exactly. Well, squares are rectangles. I never said that it wasn't a rectangle.
I guess that's
All right, so that's how we would solve this one. So this is a problem where it's like, okay, you got to do a little bit of setting up. But once you set up, all it is it's exactly the same type of problem that we just did. Namely, if you have a quadratic, how do you find the minimum or maximum value? You just need to find the vertex, okay? Just need to find the vertex.
We're not going to know that. Like, we have to memorize that formula, right?
Memorize what formula?
For the v equals to...
Your question is, should you memorize this? I'd recommend it, but you could get by without memorizing it as long as you're comfortable with completing the square. Does that answer your question? But yeah, you'll need some mechanism by which you can find the vertex of a quadratic. So whether you want to memorize the formula or if you want to memorize the method by which you get it into vertex form, that's up to you. I'm not one of those picky math teachers who wants you to do it my way.
But will we not have to multiply the two sides by each other then? To get
Oh yeah, so if you want to answer the question to find the maximum area possible, yes, you would have to, the maximum area would then be 120 squared, right? Which is like 144,000. Is that right?
It's 14.
It's 14,000, yeah, you're right. 14,400. 14,400. Yeah. All right, so that's how we do that problem. Any questions on that one? Okay, let's move on to 2.2. There was a question on that one. Oh man, did I only assign 2.2 part A?
Yeah.
Damn it.
Yeah.
Okay, well. You said 22?
Yes.
Okay. All right, so let's see this one. All right, use intermediate value theorem to show that p of x equals 2x to the 5th minus x squared minus 15 has a real zero between 1 and 2. Approximate 0. Okay, well, we'll see what, I wonder what that wants. And approximate the 0 to 2 decimal places. What? Okay, I'll probably delete that problem.
That would be nice.
But let's do this problem.
23? Is that what you're talking about? Yay.
So exciting.
No, we're gonna do this one first, and then we'll do 23. Sorry?
She's still again. I'll read again.
Use zeros, turning points, and behavior to find the polynomial with leading coefficient. Okay, that one's gonna take like 2 seconds. So let's do this one. This one is more interesting. This one has a lot more meat on it. So what does the intermediate value theorem say? Can someone sum it up for me just in layman's terms? Can someone sum up what the intermediate value theorem says?
Like, for like A and B,
Mm-hmm.
and A is less than B,
Yeah.
then, and like F of A is less than F of B, then you
Mhm.
have like C and D, something like that.
Something like that, right? There's all these A's and B's and C's, and we're plugging them into the function, and then something has to be true, right? But in like extremely simple terms, it says that if I start on the first floor of the building, and then at some later time I was on the 10th floor of the building, then at some point between time A and time B, I was at every intermediate floor, yes? Agree? Does that make sense? That's the idea behind the intermediate value theorem. So if I want to say that a function has a 0 in between 1 and 2, then what I need to say is one of two things. Either the function value at 1 is above the x-axis and the function value at 2 is below the x-axis, or I need to say the other way around, and the function value at 1 is below the x-axis and the function value at 2 is above the x-axis. I need to say one of those two things, because if I have a polynomial function whose value is initially negative and then later it's positive, I must have gone through the x-axis. Agree? Okay, so that's the idea behind the intermediate value theorem. So all I'm going to do here is I'm plugging in p of 1. What do I get? I get 2 minus 1 minus 15 is 1 minus 15, which is negative 14. Yeah? So then p of 2, what is that going to be? Well, p of 2 is going to be 64. X to the 2 to the 4 is 16, so 2 to the 5 is 32, so 2 to the 6 is 64. And then minus 4, and then minus 15. Okay, so I take away 19. Okay, or I make it 60, take away 15. I think that's 45. Am I right about that? Yes. Okay, so that's 45. So what did we learn?
How to have the real zero.
We learned that it has a real 0, right? Because the function value at when x is equal to 1 is like negative 14. So here's the point, 1 comma negative 14. And then later on, when x is equal to 2, the function value is 45. So we're at the point 2 comma 45. I have to connect this point to this point by a smooth curve. There's no way to do that without walking over this line, yes? There's no way to do that without walking over the x-axis. Okay? So I would say by the intermediate value theorem. Also, one other thing I would have to say is f is continuous, right? Why is f continuous? Not f, p. Why is p continuous? Why should this function be continuous? What kind of function is p of x? Is it a quadratic? No, it's like one of those bigger ones, right? I guess technically the word is quintic. But what kind of function is a quintic and a quadratic and a cubic? They all fall under a class of functions called polynomials. In fact, it even starts with a p. Okay, so p is continuous because p is a polynomial. Okay, so that's the intermediate value theorem. Any questions on that one?
you want us to write that out if you have on quiz?
Yes, if you want to apply the intermediate value theorem, it is crucial that you state that the function is continuous. Otherwise, it's not true.
Could we show it to you on like the arrows? Like if we use like a graph and like draw the arrows on the ends, would that count or not? If we were to like draw like a graph like I did on there, and just put like the arrows on the ends of like the connecting line, would that count or not? Or we have to like write it specifically.
Here's what I want to see. I want to see something like the function is continuous.
Okay.
And then I want to see something like the function value at one point is negative and the function value at the other point is positive. That's what I need to see. And then you need to say, by the intermediate value theorem, there is a 0 in between.
Why does it have to be continuous for this to work?
Well, let me show you a non-continuous function. Here's a non-continuous function. You'll agree with me that the value of the function at this x value is negative,
Oh, yeah.
and the value of the function at this point is positive, right? So, does the function have a 0 in between? No, right? It doesn't touch the x-axis anywhere. So, this is a function that's not continuous, right? So, the idea is, look, you can only say that I had to have walked over this x-axis here if I had to have drawn a smooth curve from point A to point B, right? And the fact that I draw a smooth curve is what is known as continuity, right? I have to draw it without picking up my pencil. Whereas this one, I can skip over, I can jump and skip over the x-axis and I won't have to touch it. Does that answer your question? All right, let's do this one now. So finally, we're making it to your problem, Emma. Sorry it took so long. What does it look like? It looks like this, kind of. Oh, man. And then it bounces and goes down. And it looks like we pass through at 5, and then we touch at 1. Sorry, -5, and then 1, yeah? Something like this, okay? And so the question is, find the polynomial of least degree whose graph could be shown above. Okay, so what are the features of this graph?
There's
That-
zeros at -5 and 1.
Yes, we have x equals -5 is a 0. And what is the multiplicity of that 0?
1.
It's probably 1. Well, it could be 3, it could be 3 or 5 or 7 or any odd number, but we're supposed to find the polynomial of least degree. So we want to make the multiplicities as small as possible. So we'll say 0 with multiplicity 1. X equals 1 is a 0 with what kind of multiplicity?
Even.
It should be even, and if we want to make it as small as possible, what's the smallest even number?
Squared.
Is 2. Okay, so how about the...
Could we see the figure?
Sorry, thank you, Jesus. Where is my thing? All right. Sorry about that. I can't believe you guys let me go for that long. Okay, so x equals -5 is a 0 with multiplicity 1 because we pass through. X equals 1 is a 0 with multiplicity 2 because we bounce off, okay? So this looks something like, f of x will be something like x minus 5 times x, x plus 5 times x minus 1 squared. Yeah? Something like this. Is there anything wrong with this function? Could this function have this graph? Or is there anything wrong? Yeah, this is a cubic polynomial. Cubic polynomials normally look like this. But ours looks like
What's a negative?
reversed, right? So this one's going to be negative. Okay, here's how you can tell. Take the limit of this function as x goes to infinity. When x becomes really, really large, this is like a big number times a big number. This would be infinity. But we can see on the graph that it should be negative infinity. So that's why we should put a negative sign here. And I would be happy with that. This is the polynomial of least degree that the graph could have these features. Namely, the end behavior is up on the left, down on the right. And we have a odd multiplicity 0 at 5, negative 5, and we have an even multiplicity 0 at 1.
I think the problem is like asking for it like completely simplified though.
Okay, so that's no problem at all. We can just FOIL this out, right? This would be negative x plus 5 times x squared plus 2x plus 1. Not plus 2x, but minus 2x, sorry. And then this would be negative x cubed minus 2x squared plus x plus 5x squared minus 10x plus 5, which would be negative x cubed. All the x squared terms are negative 2 plus 5. That makes 3. So positive 3, but make it negative. We get minus 3x squared. And then the x terms, we have plus 1 and minus 10. So it's minus 9, but we make it negative plus 9x. And then finally, we just have 5, but make it negative, so minus 5. So that would be my answer. Is it clear how I did that? A little confused?
No, it's fine.
So how did I go from here to here?
You just
I foiled,
yeah.
right? I foiled. That's how I got that. And then next up, what did I do to do this multiplication with these two? I distributed the x onto each of those terms, and then I distributed the 5 onto each of those terms. And then I combined like terms, and I had to handle that pesky negative sign by making everything negative that was negative, or was positive, and making everything positive that was negative. Okay, but my goal is not to go through this kind of computation. I think as long as you could get to here, I'm confident that you could probably finish that off, right, on your own?
Yeah.
Does that make sense? So I went through that really fast, so you don't need to do it that fast on your own. I just wanted to show you generally that's how you would do it. You just FOIL everything out.
Yes.
Okay, so that's that question. We got 8 minutes. Anyone got another one that from the homework that you want to study?
I'm sure you have
Someone here goes on the quiz.
You're all relentless. Actually, I don't know what's on the quiz.
What?
Did you not make
haven't
it
made it
I
yet?
haven't. No. We'll probably make it.
Well, we're inspired off of what we went over today.
Can you not put anything on 2.2 Part B? Since we didn't.
Yeah, I won't. Since I didn't assign it, I can't.
Isn't there 2.1 not 2.2 though?
2.2 part B, I forgot to assign.
I was
So
saying the quiz doesn't go over 2.2.
it does go to 2.2.
Wait, it does?
Yeah.
Oh, I thought it said 2.1. Okay, good to know that.
Okay, let me find a good one here.
That is 6 at 2.2 then.
What is this?
For this. Oh, is that the graphs?
Oh, yeah, that was
The
the-
graphs
that
I was
was the
trying to figure
graphs,
out?
yeah.
Yeah, I remember that.
Oh, I forgot about that.
Oh, 24 is another version of that, kind of.
Well, I mean, I got it for something we can.
Let's talk about end behavior.
I can sign all tomorrow, so
I don't get like
you're going home.
what that like I know what end behavior is and that it goes up or down and like whatever. But like the actual like ABCD, like how it's formatted, like written out is just so like
You mean like where I numbered all the different like descriptions of the graph or whatever?
No, like when you go to like the question, and then
Yes.
it's like fx, like
Ah.
arrow. That just like it confuses me.
Yeah, that notation is a little bit weird. Basically, it means this. If the limit as x goes to infinity of f of x,
Which is why.
if it is infinity, then you can translate this into their language by saying as x goes to infinity, f of x goes to infinity.
Right. Okay.
Okay, same thing. It's just a little bit different way of writing it. Okay, so let's talk about this function here. Oh, I didn't even put it on the screen. Okay, let's talk about this problem here. Okay, it's a problem where we're supposed to determine the features of the graph. Okay, and the features we are supposed to describe are the end behavior. Okay, and the end behavior of a polynomial is like, okay, a polynomial generally, you know, it comes in, it does a little bit of wiggling, yes, and then it goes off and does something else, right? So the end behavior is, well, we're talking about after the either completely before any wiggling has happened or completely after all of the wiggling is done, which directions are we headed, right? So it's what is happening to the value of the function when the x value becomes huge and positive or huge and negative. So what was the thing that we learned about finding the end behavior of a polynomial that is going to become useful in this problem? Do I need to worry about 3x? No, why not? Because it's not the leading term. Why not? It's in the front. Seems like it's leading to me. Well, the leading term is the term with the highest exponent, right? So the only thing that matters is the leading term, which in this case is negative 2x cubed. We got to take that negative with us, okay? So negative 2x cubed. So what happens to this number when x becomes really, really big? Well, I will take a really, really big number and then cube it and then multiply by negative 2. Is that going to give us negative infinity or positive infinity?
Negative.
Why negative?
Because if you're multiplying by a huge positive number, it's still going to be a negative.
Exactly. I take a huge positive number, multiply with a negative. That gives me a negative number. So the limit as x goes to infinity is negative infinity. What about the limit as x goes to minus infinity? Is it going to be the same or different? Are we going to get the same thing or something different when we do negative infinity?
It'll be different.
It'll be different, right? Because if I cube a negative number, it'll be negative, right? So this is like negative 2 times negative infinity cubed, right? When I take a negative number and cube it, I get a negative number. So this is the same as negative 2 times negative infinity, which is positive infinity, right? You can also tell that this is a cubic function, right? And a cubic function has opposite end behavior on both sides. A cubic function will either look like this or it will look like this, right? That's the options for a cubic function, right? It's basically either it's up on one side and down on the other side or vice versa. Okay, so this is the end behavior of this function. Let's try to graph it. Let's take it one further step. I think we can graph this. Well, what should I do if I wanted to graph this? Aside from the end behavior, what else matters? The zeros, right? What are the zeros? Let's see. We have x times 3 minus 2x squared. So if we think of this as a difference of squares, we can think of this as negative x times 2x squared minus 3. Think of it as a difference of squares. We get square root 2x minus square root 3, and then we get square root 2x plus square root 3. So the zeros are x equals 0, x equals square root of 2/3 and x equals negative square root of 2/3. So if we get those as our zeros, let's draw a picture. So we need 0, negative square root of 2/3, and then positive square root of 2/3. And then what happens? The end behavior comes into play as well, right? And also the y-intercept. What's the y-intercept? F of 0 is 0. So we know we pass through the origin. And our end behavior should be negative on the right and positive on the left. So we should come down from on high on this side, pass through, and then pass through, and then pass through, and go down. Okay, so something like this could be what we get. Okay, so that'll be it for today. Everyone stay safe out there. Don't get caught in a flash flood.
Have a fun tropical storm.
Yeah, have a good tropical storm.
It's hot. It's all hurricane. No, it's a tropical storm now.
Tropical storm,
It's